Okay, so let's continue doing problems. This is another problem. A 400-foot high tower stands on level ground, anchored by two cables on the west side. The end of the cables closest to the tower makes an angle of 70 degrees with the horizontal. The two cable ends are 100 feet apart as shown in the figure. How long are the cables? Okay, so this is nice. They drew a figure for us, and that's really helpful. And with the help of... it's really nasty now. It's all wet, too. T-shirt of disgust, ladies and gentlemen. Check it out. It's getting moldy. Okay, I promise I'll wash it soon. Yeah. Wipe this down a little bit. Okay, so as I said, we were lucky. They made a picture for us, and this is really helpful. So here is this tower. It's probably some kind of radio tower that is tracking the signals from the UFOs, which want you to do your homework so your brains are nice and tasty. Okay. So anyway, we're given that this is 400 feet high, and now there's two wires. One's here, and this is in their picture, so it's pretty safe that this is what we're supposed to be looking at. So here's the two guide wires, and these are 100 feet apart. We're supposed to figure out the length of these wires, right? And let me try and make this a little more even. Okay. So this is our basic picture, and okay, so what we need to do is start putting in information, and I forgot this. This is 70 degrees. This is also given. Okay, so you'll notice that there are two triangles here. There's this one. Oopsie. There's this one right here. And then there's the bigger one. Notice that we have a right angle. This is 90 degrees, 70, 20, and I'm assuming it's a right angle because the tower is supposed to be straight up, right? Why did I do that? Well, I have some information here, okay? Okay, so, and not all the UFOs are here to eat your brains, but the ones you guys will meet probably are. So make sure they're nice and juicy and smart, and the UFOs won't be mad at me. Oops, I'll put the 400 back in here. So we have this height as 400 feet. We have some angles. Let's just start filling this in and figuring out what we got here. This bit right here, I know that the tangent of 70 degrees is equal to this divided by this, and I guess I'll call this x for right now. So this is equal to 400 feet divided by x. X is also in feet. You'll notice the feet cancel. Solving for x, I have x is equal to 400 feet divided by, and that is x feet, divided by tangent 70. And because I'm solving for x, I'm back in feet because length is in feet or some unit of length. Let's see what x is here. And I actually brought my calculator. So 400 divided by 70 tangent. This claims to be 145.58809. So this is 145.58809. I'm going to leave that for here. As I said, this book tends to abbreviate to the 10th position. I like going to the 100s just to make it a little more accurate. My estimation of this would be 145.56, and these are in feet. Well, why did I bother doing this? Well, look what we got. We have this, this. We know this is a right triangle. This squared plus this squared equals this squared. So this should be, 145.56 squared plus 400 squared square root is 425.66. Okay. So this cable length is 425.66, and it's 150 blah blah blah. Basically, this is our estimate right here to the hundredth place. I want to do one more thing just to make sure I haven't screwed up anything, and that's just to check this. And it's probably overkill at this point, but let's use another identity here. We know that the sine of 70 degrees is going to be this divided by this. This should be 400 feet divided by 425.66 feet. Let's just see if this comes out right. I'll check out what it's supposed to be on the calculator, and then I'll check out what the actual fraction is. So 70 degrees sine. This says 0.939692 blah blah blah. This is going to be 400 divided by 425.66. This is 0.939717. Where did we diverge here? So 0.393. As you can see, the approximations, the difference in the approximations starts showing up in about the, well, so here's tens, hundreds, thousands, 10,000ths place, something more or less right in there. A good question is that good or bad? Okay, so what we figured out then is that this seems to be a pretty good approximation for this cable's length, and we didn't even use the law of cosines here, we just used what we know drawing this picture. Similarly, even though I can figure out that this is 110 degrees here because there's 180 degrees in a straight line, I don't know this, I don't know this. What I do know is this, how long this is, how high this is. So basically this is, I guess I'll write it this far down. This is 245.56 feet. This is 400 feet. I can figure out how long this cable is simply by taking the square root of this squared plus this squared. Pythagoras is going to help us out a lot on this, so we don't got to do much mucking about. 245.56 squared plus 400 squared. Square root is 469.36. And this is in feet. Okay, and I've already checked these answers on the back, and I hope you will too, just to make sure that these are coming out right. And these are more or less it. As I said, the book has a habit of going just to the tenths place, and I like going out to the hundreds. It just depends on what you're going to do with these. So that's it for this problem. Mr. Producer, I believe we have one more section for law of cosines, so we're going to come back for one more section of law of cosines.